Just wanted to say good morning to everybody. Good to see people from both near and far, like Stephanie said. And I'm really looking forward to going over the very first AIXM webinar. So it's a historic occasion here, considering how long we've been working with AIXM for, must be close to 15 years now. So let me go ahead and share my screen in a sec here. Can everybody?
Yeah, we can see it.
You can see the screen? All right.
Try the slide.
Yeah.
I was going to say, too, we have people tuning in from Canada, Finland, Chile, the States. It's really cool to see. So thank you for sharing that.
Very good. Yeah, so just quickly to go over the agenda today. Actually, also thanks for Mark for showing up, and he's going to help with some of the Q&A. If you have any questions, you can just keep those coming, and then we'll stop for questions once in a while and have time at the end as well. So definitely want to get your feedback because we like to hear from people actually using our tools in whatever context that might be. So just to go over the agenda quickly, we're going to cover what is AIXM and for anybody new to that topic, and also a quick intro of who we are at SAFE and what FME is. And then we'll dive into some workflows around visualizing data, converting between AIXM and GIS, which is a very common workflow back and forth. And then we'll talk a bit about validation, enterprise integration, and all of the different versions, flavors, and alternative encodings that we might come across before we summarize. And all along the way, we'll have a number of demos and examples. So here I'll just drop the camera for now. All right. So a quick intro to what is AIXM. It's Aeronautical Information Exchange Model, and it was brought to us by the FAA and Eurocontrol. And the whole purpose of it is to provide a digital format for aeronautical information services. It's because AIS, or Aeronautical Information Services, is getting increasingly complex and made up of very many different interconnected systems, suppliers, and customers. There was a big need there to promote standardization and automation. Also, there's a push to go from paper products over to digital. And so that's the whole purpose of AIXM, is to support that level of integration. In terms of what's covered in the scope of AIXM, airports, heliports, taxiways, all of the surrounding facilities, so the stuff on the ground, and also everything related that's up in the air, or the airspaces, procedures, routes, flight restrictions, and all of the nav aids that support that. And these are just some of the terms used specifically within AIXM for the functional groups. So quickly, just a very quick example of this before we dive into more detail. Here's Chicago O'Hare with the various runways, taxiways, and vertical structures, and that's what you would see on an air navigation chart. And this is the same thing within FME. And there's the workspace I use, very simple workspace to go from AIXM 5 over to OGC KML. And this is the output. And I'll just pop this up quick, just so you can actually see the sort of live data, I guess you could say. So there's the background map. You can see everything's properly georeferenced. I can click on a specific runway. And the point here is that FME doesn't just give you the geometry, but also the rich data model underneath, which shows the elevated surface and the various surface properties, in this case, concrete. And the various vertical structures, we'll look at those in a minute. So that's the actual source AIXM 5 file for Chicago. And in terms of the output generated by that workspace, we can do a quick sort of fly through here of, so here's in Google Earth, you can zoom in, and we've preserved the actual attribution. Oh, actually click on the structure here. So you can see the various attributes. And if I open this up, you can see the AIXM feature types associated with that airport. Yeah, and then right down to the actual GML IDs that we've mapped to KML ID. So we can come back to some of these data sets later. I just wanted to give you a quick kind of fly through of what AIXM data actually looks like. Here's something a little bit closer to home from CTAC, the minimum vector altitude airspaces. And again, you can see the airspace volumes with the minimum maximum altitudes. That's all modeled there as well. So what are some of the challenges of AIXM, and why would somebody need a tool like FME to support that? Some of them, the challenges, we'll look at both 4.5 and 5.1. And so for 4.5, the big challenge there, that's when I got started with AIXM probably close to 15 years ago. The challenge there is that it's not geometric. So you have basically parameters that define things like the endpoint of a runway and the width and the length. So that has to be interpreted to actually get a geometry. It's highly normalized, so you have multiple tables to describe, let's say, one runway, and it's object-oriented or XML-based. So a lot of challenges there to work with the data. And then with AIXM5 came the challenges of the GML standard, which is inherently quite complex. Obviously, AIXM is a profile of that. And again, a lot of complex relationships between the feature types, namespaces, and similar challenges to AIXM4 in terms of being object-oriented and having to validate against a schema. So this is just a quick note on what I'm talking about when I say object versus relational. So a relational table would be like a flat table, CSV file, something you would get in the database. And so one record, one row, whereas we don't really have a record per se. When you're talking about XML, you have elements and properties. And so there's often a lot of nesting. There could be one-to-many relationships, the equivalent of a list. And so all of that basically requires a transform to go between the two. So a few words about SAFE and FME before we dive in a bit further. SAFE software, we've been around 25 years, and with our mission to support data integration, harmonization, and automation, we have more than 10,000 organizations around the world using our software in more than 120 countries, and a very strong partner network, more than 150 plus partners worldwide. So I'll mention a few of them later on. In terms of our technology partners, we work with pretty much all of the leading geospatial software providers out there, whether that's ESRI or Autodesk or Bentley. And then we also work with standards organizations such as the OGC. And then in the industry, in the aerospace industry, we've worked very closely with a lot of the government agencies, federal agencies such as NAV Canada or Transport Canada, FAA, and then also airports in regional space like that. Okay, so ultimately our mission is to help you maximize the value of your data wherever it may be, and that involves connecting, transforming, and automating your workflows. We have FME Desktop. So for those of you new to FME, the desktop product is where you build and author your workflows with drag and drop of your data sources and different transformation steps. And then with the push of a button, you can publish that workflow to server and use our new automations platform to orchestrate different workflows together and tie them into external events. And then ultimately that can be published to the cloud and deliver data to mobile apps. So what are some of the opportunities unique to AIXM in regards to FME? This isn't by no means comprehensive, but just a sampling of some of the applications. There's airspace management, so moving data from in and out of AIXM for relevant airspaces. The automation of your enterprise, whether that's a government agency or an airport, managing facilities such as airports. So we've got a fair bit of experience there, and we've seen a lot of implementations at the airport level, and managing specific restrictions such as obstacles or UAVs. And obviously that's been a big growth area in the last few years. So some of the benefits of working with FME for AIXM is the first and foremost with AIXM 5, we have invested heavily in our GML infrastructure. AIXM was one of the things that pushed us in that direction, as well as the EU Inspire initiative. And so both of those involve complex schema, and we basically built an underlying infrastructure that is driven by the application schema. And so a lot of that schema modeling, interpretation, and rendering is all automated directly from the application schema. And so that way you can focus on your features, not on being an XML programmer. So most of what we're talking about today, we come in and out of the XML, but by and large, if you're familiar with FME, you can work with the AIXM. You don't have to be an XML expert. And this makes extensions easy, namespace handling, all that stuff is kind of handled under the hood. Ultimately, though, you do need to get to wrestle with the object-oriented data model and how you're gonna, you do have to understand your data model, essentially the UML of that, and how to convert or transform between the data model and let's say whatever your destination is, your database, and understand what's required for validations as well. So here's just a quick snapshot of going between two different standards, and ultimately from our experience, moving between standards is definitely easier than let's say ad hoc between an ad hoc schema and a standard. So the basic steps here you'll see repeated in a number of different workspaces. We consume the data, and then we do a join of across multiple data sources. And then there's often a schema mapping step from the source to the destination. So there's a number of attribute copiers there, or changing case. And then we typically need to generate geometry. So we have geometry property setters for that. And then there's often some of the nesting involved in terms of building the geometry. We have to use aggregators as well. And yeah. And then the other key part that we've often come across is the setting up the hierarchy with parent IDs. So you have GML ID and the parent ID, and that helps you define the hierarchy between features. So here are some of the demos we're going to go through. We've just had a quick look at Chicago and an Inspire to AIXM5 workflow. That one, by the way, is available on our knowledge base, so I won't run it right now. And we'll dive into some visualizations in a minute. I was just going to quickly check with Mark. Did you notice any questions so far, or any feedback, or did you have any comment there before I jump out? Keep moving.
Well, maybe just at some point highlight how much easier AIXM5 is than the old AIXM4.
Yeah, sure, that's a good point. And I do have a fairly simple 4.5 to 5.1 migration workflow, and so we also have, I think my plan is towards the end, during the Q&A time, the time I have allotted for Q&A, we can definitely look at a few sample data sets. So that's something we could dig into. But yeah, certainly the GML handling is a lot easier, and when we get to some of the supporting formats as well, like FIXM and WIXM, some of those work right out of the box with a GML reader. You don't even need a specific format reader for those. So we'll see some of that later, but yeah, that's a good point. Okay, so why don't we dive into visualization. So FME has a lot of great visualization tools. Basically, you can do anything from very simple visualizations, let's say publishing to KML for Google Earth, like we've just seen, or going to 3D PDF. So those are fairly easy to distribute. And then we also support more sophisticated 3D rendering, let's say to Unreal engines, a gaming engine like Unreal, or to Web3D formats such as Cesium or i3s. And FME also scales very well. That's something we're not, don't have a lot of tons of examples today, but whether you're dealing with kilobytes or gigabytes of data, FME can handle it. And we also have lots of tools for conversion from 2D to 3D, as we'll see in a few minutes. So here's an example from Grafton, Grafton Tech is one of our partners, and it's a client data management system for visualizing airspaces, and they've deployed this in FME Cloud. And here are some airspaces, sort of approximations of airspaces. Basically, these are more flight restrictions based on distance to airport for, let's say, UAV flight planning. And in terms of visualizing, we've seen a couple examples of KML. On the left here, we have a 3D PDF of YVR. So you can just see it's relatively easy to convert data to commonly accessible formats. Not everybody has an AIXM viewer. And in all of these cases, it's relatively straightforward to preserve the attribute schema as well as the render the geometry. So, and I'm just going to pop up this data set. One of the challenges I probably glossed over a bit was the just the challenge of getting a hold of data. And so, we're going to make these slides will be available, as well as a number of the examples I'm using today and the data sets for them. And that certainly helps with the learning curve to actually have some, real world data to play with. So let me just zoom in here. So this is some fairly comprehensive data set I came across. I think it was from the Eurocontrol GitHub or Confluence page. And so they have I have links to their global data site for various examples. And so here we'll just have a quick look at an airspace. So I just wanted to underline the whole aspect. And to Mark's point about the ease of if you were to build this feature from AIXM 4.5, you would basically just get a bunch of border vertexes, and you would have to build up all of the lines from the points, and then you would have to build a polygon from the lines, and then you would have to extrude the airspace. So it's a lot of work to assemble all of the AIXM 4.5 to assemble all the bits. All of that happens, all that geometry handling is done automatically by our GML infrastructure for AIXM 5. And so the other thing is we handle a lot of the nesting in the geometry model. So you can see the various nested components here. So we have at the root level, there's a class geometry, and then various geometry components, airspace, volume. And then when you get down to the polygon level, that's a horizontal projection and then curve. So that basically parallels the data model in AIXM. I just wanted to show a quick example of that. And then there's also some designated points as well in there. Let me just click on an individual vertex here. So that's a bit simpler when you get down to a designated point. All right. So I just wanted to this is a updated version of that AIXM 5 to OGC KML workspace for O'Hare. And you can see that it has the same basic flow of extract the AIXM data, do the schema mapping, apply the styles for the destination. And in the bottom here, you can see that there's where we handle the 3D extrusion. So that's essentially going from, because the data is not actually stored in 3D volumes, so we take the surfaces and extrude those by the elevation to get the actual 3D shapes for KML in this case.
Okay, let's have a look at a round trip going from AIXM to GIS and back to AIXM. In this particular case, we'll be going between AIXM 5 and Esri geodatabase. So this is the source data from Austria. So obstacles and vertical structures from the area near Vienna is what we'll look at. And let's just start off by looking at the actual source data that came from their geoportal. Read that in with the XM5 reader. And we'll notice fairly quickly when we have a look at it, it takes a minute to load up, that FME Data Inspector shows you, as we saw earlier, the complexity of the data itself. So we have basic message, which is the extents of the data. And then if we click on one of these vertical structures, we see the geometry associated with it and all of the properties. And what we'll do is zoom in the area around Vienna. And I found right on the dot of a Vienna, which is kind of easy to track, is Stephen's Dome. So that's the St. Stephen's Cathedral. And so if we look here, we have a bunch of the AIXM properties, and then we have the complex geometry, in this case an aggregate of point. And so you can see the geometry name, properties, things like the type of vertical structure parts, so the name for the object, and in this particular case, a elevated point of a building, including the actual height in meters, things like that. So in terms of how we move that across to GIS, and this is the workspace for reading that. So reading the AIXM data and writing to geodatabase. The main process steps here are consuming the data and then doing schema mapping. To start off with, we have to replace dot with underscore because the destination format of geodatabase does not support dot in the field names. I'll just point out here that if right when we add this, you can see everything's red here. You can actually right click on this and go auto connect, and it will do sort of similar name associations like things like case. It'll ignore case or dot versus underscore and make those connections for you, and then you can right click and replace with attribute mergers. So that's another way of doing this, and we'll see that in subsequent workspaces. For now, we'll just go back to what we had. And the other thing that we're going to do here, I'll go ahead and fire this off so it's running in the background, is we will take complex objects, in this case, that have nested series objects. And because a relational database does not support this kind of nested list structure, we have to explode that out and write a separate record for every element. So that's what the list exploder does. And then finally, down here, we have some, besides the schema mapping, we have some geometry simplification. And so this geometry property extractor, the geometry property extractor, what we do with that is if you leave everything blank, it will extract, essentially it's like a wildcard operation, extract all of the properties from the geometry and write them onto simple fields, which is a lot easier to write to a relational database. And then we deaggregate the geometry itself and keep the geometry name so that we can reassemble it later. So if we can pop back here, and we'll look at this similar spot in the data for Vienna, but in this case on the geodatabase. Just head up here. Yeah, here's the geodatabase. Select that. Takes a second to bring that in, and we'll just turn on, again, we'll turn off the extents and zoom in around Vienna. And just clicking on that dot, we can see here we have Stevens Dome and some of those geometry properties, and a simplified geometry, in this case just point. Okay, and then the final step in that whole workflow is going from geodatabase and back to AIXM. And so that's essentially the reverse process, where we put the dots back in the names so that we satisfy the structure, the property names required by geodatabase. Sorry, in this case, the property names required by the GML. Setting the geometry names in some cases, and feature type mapping. Here we have to take all of those detail records and roll them into one complex object with an aggregator. And so we just select the properties that will go into that list structure and then write that for the obstacle areas. Yeah, there's the obstacle list structure there. So that's again the reverse process of from AIXM to GIS. We're going from GIS back to AIXM. And then finally, we have to rebuild that complex geometry with all of the properties in there. I didn't have time to tag every property, but enough to satisfy the AIXM writer requirements, validation. So we set the geometry names and a number of the properties here. And rolled up the geometry using a sequence of geometry property setters and aggregators to write to the output geometry. So we'll go ahead and run that. Again, this is going to be reading from that geodatabase, writing out to AIXM5, and you'll notice that the output validation is set to yes or on. So I'll just take a minute to write all that up. And when that's done, you can see there's some kind of a warning around coordinate system assumption, but there's no validation error. And so I'll just go ahead and open the output, and we'll look at Stevens Dome, but this time from the AIXM5 data that FME wrote. So that's the one that we wrote. Pull that in. We'll just turn off that extent. So if we zoom into Vienna, we can see the elevated point or obstacle associated with St. Stephen's Cathedral. And so there you can see the name and then the complex nested geometry and elevated point. So it's got the right geometry names. Yeah, vertical height 137 meters and some other properties there. I think that's relative height versus the absolute elevation. And again, there's some finer details there that may or may not have been mapped, but FME has the capacity to map all of those if you go through it all. So that's essentially the round trip, showing that we can read AIXM5, map it into a relational database, a flat structure, in this case geodatabase, and then read that geodatabase and write back out valid AIXM5 data to essentially complete that round trip. And modeling all of the complexities of the nested list structures and complex geometry that the GML has in its data model.
So what are some other applications for AIXM? Certainly we've got some good examples of obstacle avoidance in planning. And we've been working with, I guess, yeah, Finavia is a good example, and LAS, we'll see. So for, I guess this example is from YVR. And so here FME is used to handle all the complex calculations around what could be 3D obstructions, and then build up a surface model of sort of the minimum altitude where you can fly safely. So this was done for YVR. And so basically the data source here is reading from Excel, and that is used to generate both HTML reports as well as write to an Oracle database for both the map and feature info from the obstacles. And here's another one based from Finland, from our friends in Finland, using point cloud data sources. So the National Land Survey consumes these LAS map sheets from an API, and basically uses a threshold, and then any points above that threshold are used to generate an obstruction map. And so the core of this whole workflow is that point cloud filter. There's a component formula in there that says if basically ignore all points except for something above a certain threshold. And this is kind of like a heat map of elevation, heat map of where the points are of concern near those airports in Finland. So anything within 45 kilometers. So a few quick notes about validation. Validation is really central to most of what we all do on a day-to-day basis. There's no point in having data workflows and transforms and integration if we can't validate our data and make sure that, you know, bad data is caught and cleaned up. So it's certainly central. We've got quite a few tools within FME to support validation. You saw I had the validator turned on for the writer in a few moments ago, but we also have the XML validator transformer. We recently updated it to handle multiple XSDs, so you can click on both the AIXM basic message plus a few other XSDs. Normally we prefer you would click on the extension XSD and it would import, let's say, basic message as a parent, but we can handle different XSDs that may or may not include each other, so long as they're compatible. And you can, of course, validate both either syntax or schema and namespaces. And just to mention there, we also have a lot of tools for validation for things like the attribute validator, geometry validator, and whatever business rules you want to model with testers and test filters. So now a few quick words about enterprise integration. We see this as a huge area of opportunity for organizations to promote automation across the enterprise and bring disparate data sources together. Sometimes you need mirror or staging databases to support mission critical functions such as data distribution, and you know, FME gives great support for that, with the ability to convert to whatever data format is needed and streaming that out to stakeholders. Often in this case, that would involve FME server. So here's what I think is a good integration workflow example for Schiphol Airport. This is not using AIXM, this is using IFC XML, but it's essentially the same basic idea of what we would consider enterprise automation. And whenever something happens at the airport, let's say a light burns out and you want to generate a work order to fix the light, or there's a planned work where you have to take a taxiway offline, that can be an IFC XML message that communicates across essentially an enterprise service bus, in this case a BIM ESB, to whatever systems need to know about that information. And in the same way, you could do that with AIXM. And AIXM ultimately is a messaging format for generating things like NOTAMs. And so I think FME's infrastructure is well positioned to support that. So it's not just about reading and writing files, but ultimately sending messages across and between enterprises. So here's a really quick example of that. I probably won't run this right now for the interest of time, but I can have a look at this later. This reads service notices from HTML and then generates a CSV table of those notices, as well as downloads the PDFs. So this is, I guess, an example of web scraping. So we can consume data directly from a web page and convert that to XML, flatten it out, and then basically parse out the paths to pull down a service notice PDF. I will put a note in here that I am using the decelerator, so you don't want to spam some of these servers with too many messages at once and just try to suck down all the data. So just with a nod to the folks at NavCan that we don't want to overload them, and so and you don't want to also get your IP blocked for generating too many requests. So that's why we have the decelerator in there. So this is what that's the input page from Nav Canada. I can click on that and go there. So that's what the page looks like. Just a sec here. And there's the output table, CSV, and then the PDF that's downloaded from that. Let's get to the max screen. So I wanted to make a quick example of an automated workflow there. So a few words about versions and extensions. So we spent a little bit of time on 4.5, and a lot of our examples are around 5.1. So we still continue to maintain and support all of these versions. There are also extensions from the FAA and from Eurocontrol that we tested and have supported. And in a couple slides, I'll show you an example from ARINC 424 from our partners back east, Ontario Spatial DNA. There are some, I guess from our perspective, somewhat newer formats, FIXM and WIXM. And so WIXM is for meteorology or weather data, and FIXM is more about flight telemetry. So those are XML and GML standards for sharing that type of data. And all of this is part of what's called SWIM, or System-Wide Information Management. So you'll see that term. That's not really a specific format, but it's kind of like a family of formats for this whole idea of automating aeronautical information systems. So just a couple of words about our underlying XML, GML infrastructure. We have wide range of support for quite a number of XML and GML formats now. So they have a lot in common in terms of the challenges involved. So we often group them, and we have a lot of resources for that. For the XML reader and writer, our standard one, the one that's been around the longest, basically that focuses on the data, and so you can select a node within or an element within an XML data set and say, well, this is the level at which I want to generate a feature, and that's called feature path. And then for writing, we use templators. So that's kind of the older XML reader writer. We have a new XSD driven reader writer now that will handle things like metadata, ISO 19115, and any other XSD application schema. So we've had that for quite a while for GML, but for XML, more generic XML, that's fairly new, and it's quite powerful. And then we have a lot of underlying tools for XML processing, let's say like XQuery, XSLT, and the validation, which actually uses Apache Xerxes library. And then we've, over the years, had a lot of support for OGC services, but we've had a few new ones come online within the last year or so. So WCS, WMTS, and now OGC API Features. And then, of course, all of these things can be hosted on server. So I won't get into too much detail here, other than to say that you have the XML templator approach, but that's fine for like ad hoc XML, and sometimes you'll find I like this point here at the bottom, is you can actually, with the GML writer, you can actually write XML snippets instead of writing every field. So let's say if you have, you know, a field called a.b.c, which models, you know, A is the grandparent, B is the parent, and C is the child. You can either write, you know, all the values C1, 2, 3 as individual fields, or you could write to A or B as an XML fragment. And we have examples of that on our knowledge base. So the cool thing about the GML writer is it wraps all of that up so that you can handle GML just as a normal format if you want. And it handles all of support for complex geometry and multiple geometry and different names for the geometries. Yeah, so basically you're mapping directly from a schema to feature types and to fields. So just a word about our friends over at Spatial DNA. They do the ARINC 424 plugin. So ARINC 424 is a commercial standard for aviation developed back in the 70s. And that was done for flight management systems and air traffic control. And so what they do is they use FME to convert between ARINC 424 and AIXM 4.5 and 5.1. So they've got quite a bit of experience. And there's a sort of an implementation story for Frequentis down in Australia, where they use FME to do those types of conversions. So I think Spatial DNA is also active with things like UAV permitting, and yeah, so that you can check out their website for more information. Here's an example of AIXM. So that's that weather meteorology, and you can see here there's an in-cloud hazard. So maybe that was from you know, a storm or something in the mid North Atlantic. And so you can see they've defined, essentially they can mark up temporary elements like that that could come up as a warning for navigators to avoid. So that's a weather exchange model from the FAA and Eurocontrol. So now we'll talk a bit about AIXM 4.5 and converting between 4.5 and 5.1. So as I mentioned earlier, 4.5 is fairly complex in that it doesn't actually have a geometry itself. It just has parameters for geometry. And so you can have an endpoint like this, and then you have parameters for the length of the runway and the width and the bearing. And so you need to use all those parameters to generate that geometry before you're going to write to GIS or any other format. And the same thing goes for things like sectors or airspaces. So the basic workflow for converting from 4.5 to 5.1 is you read the AIXM 4.5, do whatever joins you need. Then you need to interpret those parameters to make the geometry using transformers like line builder or bufferer. All along here, I've kind of got the transformers you would use highlighted. The schema mapping and feature definition, typically that would be an attribute copier or creator. And then the geometry transformation, as we've already seen, lots of geometry property setters and aggregators. And then finally, defining some of the parent-child IDs for the GML before writing to AIXM 5. So that's what this source data looks like. And that's just basic AIXM points. And there's the data conversion workflow. And there's the output in AIXM 5.1. So yeah, and we can look at that, some of those data sets in a minute. So some future proofing. How can you, you know, protect against or manage risk of new things that are coming down the pipe? AIXM 5.2 is, I'd be interested to know if anybody has a fixed date on when that's going to be released. I think that was already supposed to be released back in December, but there's been some, I think, COVID-related delays on that in terms of when workshops can be scheduled and whatnot. So that's coming along soon, and we'll be testing and supporting that. Digital NOTAMs, I think the US is a little ahead of the curve on that one. So there's some areas that have implemented that more than others, but I have some test data we can look at. So certainly we can support reading and writing those, and as well as automated services for that. Other encoding. So I came across some GeoJSON data sets. So whereas I don't think the XML or GML isn't going to go away, because it's probably the most efficient way to do validation. Let's say agency to agency. But for consumer applications, for mobile devices, GeoJSON is just more lightweight, more efficient. So there may be, I could see more development there, and we certainly do support working with that, as well as the OGC Features API. I have an example of an AIXM service for that. And then, of course, we have emerging applications, let's say UAVs, and being able to generate restrictions and just the data volumes involved with UAVs, because some of the air traffic control, simply phoning the tower and saying you're going to fly a UAV, that just doesn't scale. And so that's really pushed automation. So here are some examples of digital NOTAMs. I've got a couple screenshots so you can see both some of the attributes, or you can see more of the full geometry model. And basically this is just from a Donlon data set. So it's kind of a fictitious test data set, but it kind of proves the point that we can read and write it. And here is a runway closure, similar idea, digital NOTAM for runway closure. So in terms of alternate encodings, I thought this was pretty cool. Came across this OGC API service. So those of you familiar with WFS, you need a special client to even see what's being distributed there. And with OGC API, you just hit the endpoint and you get an HTML page by default. And here are the actual features here. So I can click on this and get the collection. And this is just a JSON document, and then we can go in here and open that up. And you'll notice here when I type OGC, we've reorganized our OGC formats so that they all kind of show up together, just to make it easier to find them. And we can read directly from that URL, and let's hope they're still, I haven't brought it down. I have it cached locally, but there you go. So there's all of the AIXM classes, obstacles, aprons, nav aids. I'm just going to grab vertical structures so we can zoom into something familiar from what we saw earlier. So we're going to go back west, back towards Chicago. Maybe there's a snowstorm there now. We'll see. So while that's coming up, maybe I'll just pop up the log, and you can see that it's pulling down, doing a series of JSON and GeoJSON queries, paging through the data, and then rendering that. So just a different encoding, the same basic geometry model. So we have a number of locations across North America modeled here, and we'll just zoom into Chicago, and you can see that a number of those vertical structures are modeled. Zoom in a little more. This takes a little bit for it to catch up. There we go.
While that's loading, I'll answer a question I saw come in that said, can you provide us a video of this presentation? And yes, definitely, we will be sending out the video along with the slides and as much of the workspaces and data as we can send out. So you can watch for that in your email.
So you can see I guess the JSON model is slightly different than AIXM, but all the basic data is there. Yeah, so that's the OGC API feature service. And so you can basically, I have these things linked up. That's a feature query on one feature, and you can just click that link. So it's all REST based, and so that is definitely, in some ways, quite efficient way to publish data. And that's just the underlying AIXM GeoJSON. So I wouldn't say that this is an official standard yet for AIXM, but it just shows if you want to make something a bit more client friendly, there are ways to do that kind of conversion. And here are airspace restrictions for UAVs in the UK. And maybe I'll just quickly pop in there. So I think that's it here. Yeah. So while that's loading, I'll just keep going here. Yeah, well, let me just see here. So that, yeah, those are basically just, you can see London Heathrow is highlighted there. And there's various restrictions around the UK. So this is actually there's a URL here that would take you to that actual live service that's updated regularly. I'll pop that up when it's finished rendering. So just to summarize, I think we've shown kind of the tip of the iceberg here, but FME does have comprehensive support for aviation data, including all the main releases of AIXM. And central to this is our support for standards. So whether that's OGC standards or EU Inspire and various other standards around the world, that's really central to our goal for promoting data sharing and integration. We've maintained ongoing support for bug fixes and refinements for 4.5 and 5.1 and beyond, so 5.2 and when that comes out. We've made a lot of improvements to our underlying GML and XML infrastructure to support AIXM and to also scale that. And we've seen a lot of activity in the area of airports, whether that's everything from indoor mapping to managing the infrastructure and the facilities, the runways, and then of course the airspaces and restrictions around and obstacles. Didn't really have time to dive into FME Server, but there's been a ton of development there related to automations, which make it ideal platform to take your workflows and make them available across your organization and to external stakeholders. And so ultimately, FME supports your workflows, whether that's airspace management, obstacle avoidance, UAV restrictions, or just general enterprise automation. And you're future-proof for things like future and new encodings that might come along. Here was that UAV restriction data. And so you can see these are basically just restricted airspaces to regulate UAV activity around the UK. So tons of resources for you available. There's the GitHub and home for AIXM, AIXM.aero, which is hosted or has been published by FAA and Eurocontrol. I really found that Confluence page for Eurocontrol quite handy, so they've done a good job of maintaining that. And the FAA has a good intro and overview of what AIXM is, and also a number of resources there. NATS from the UK, ICOA, even the Wikipedia page for AIXM I found quite helpful in the history, and the OGC Aviation. So if you want to get connected to community, the aviation community related to geospatial, the OGC is a good place to do that. I've got a few other examples here, but in the interest of time, we probably won't run through them. So I would actually like to open it up for questions. Were there any other, Mark? I don't know if you noticed any questions while I just kind of step through some of these examples.
Yeah, we had a question for AIXM 5.1. What would be the timeline for us for supporting the Xlink href geometries in 5.1?
Yeah, well, we've been working on that. I'm glad you asked, because I wanted to put that on one of my closing slides, and that's certainly been a hot topic lately. I was talking with development about that yesterday. One of our big challenges there is that, and this gets into the weeds of the spec, but we are going to add an advanced, so in terms of timeline, it's probably a week or two away where you'll see an advanced parameter to resolve Xlinks. But the problem is that according to the GML spec, Xlinks should be from a geometry to another geometry. And so far, the AIXM data we've seen, the Xlinks from inside the geometry are pointing to other objects, other elements. And that's kind of violating the GML spec. So if you could send us some sample data of what you want us to read, because we've been having a bit of trouble getting that, that would certainly help. And because there are different flavors of how Xlinks are used. So the short answer is our GML infrastructure can handle Xlinks. We do it for S121, which is a maritime limits format. We do it for City GML, and some cases Inspire. So we have the infrastructure to handle Xlinks, but it does need to be done in a consistent way. So just seeing lots of wind farms around Austria and Spain here for obstacles. Were there any other questions, Mark?
Yeah, one about extensions. I noticed in one of your slides you said we support the FAA and Eurocontrol extensions. Are there any other problems supporting other extensions that might be out there, or would we add that?
Yeah, I so far haven't seen any problems. I did notice, I forgot to mention, for the digital NOTAMs that are there, and if you want to open them up, there is a trick. I'm going to actually show you this. So just reading extensions, sometimes what you have to do is in the parameters here, there are some options of whether you use the schema or data set to get the schema. And for the NOTAMs, I had to ignore exercise schema location on, because there were some problems with the schema location. Some of those links were not resolving properly, or there was conflicts in the namespaces. So sometimes you have to play around a little bit with some of the GML parameters in order to work with different extensions. But yeah, so far, I mean, yeah, digital NOTAMs that's one good example. I guess that's essentially the NOTAM extension or profile for AIXM. But yeah, if you have an extension that you're working with and you want us to test it, please send it to us, and we can have a quick look at it and let you know if there's any qualifications about how we can or can't work with it. While I'm in here, I'm just going to mention, here's an example of where you would maybe use an XML template to write an XML fragment to a field within the GML. I was going to show you that earlier. Okay, any other questions, Mark?
Well, I think somebody just wanted to know about that navcan data that you were working with. Was that coming from a live website, I think?
Yeah, it was. So I can show you that quick. Let me just pop out of here. Yeah, that's the actual live website. So this gets updated. So you can see April, I guess these are effective dates or forecasted dates when those will be active. And if I go to the demos here, this is the actual demo for retrieving that. So that just pulls the data straight off the website and then writes to the CSV, and it downloads the PDF files. So the key here, if you're ever going to work on that, is the HTTP caller. So that performs the GET operation. So this is the HTML table reader. It's relatively new in FME, and that's pointing directly at that navcan link. And then it's just, in this case, I'm reading everything off that table, and I'm only downloading things that are published in for 2021. So I put that as a search term, and I put max features at 10, so I don't go try to download everything by mistake. So that's essentially what that's doing. And yeah, those are the records of what were downloaded for Thunder Bay, Red Deer, and then this all is written out to this folder.
Yeah, perfect. And of course, that would be a classic example of something that you'd automate an FME server to periodically scan that and get the latest data.
Yeah, maybe you only look for deltas. So you might keep a local table of what you've already downloaded and then just download stuff that you haven't seen yet, for example. That'd be another way to do it. Yeah, but good question. So coming up to the top of the hour, I think what I'll do is I'll just give my wrap up, and then I'll hang around for a couple more minutes for if there are any additional questions. So just to mention that we do have the community and our knowledge base. So there's lots of resources there, both for AIXM and for GML and XML. And certainly do feel free to ask any questions you have on the community. Sometimes someone overseas, if you're in a different time zone, might respond before we wake up on a Monday morning. So definitely keep that in mind. There are quite a few resources in terms of various customer success stories, and I did want to give a nod to our partners. I mentioned Spatial DNA. We've also got like Tensing, a number of partners over in Europe, such as Tensing, that has done work with Schiphol, and then Swaco and Conterra. They've both done a fair bit with AIXM. And then Concert Tech, closer to home, has done a number of fair bit of work with airports. So yeah, and I believe One Spatial as well. So you can just check out our partners page to see a list of those. And yeah, we've got presentations by the folks at Nav Canada and a number of other examples that you can check out related to, UAVs, various airports. So lots of material there. So I won't go through the updates. I think the Xlink one was we recently did a UOM fix. I had to do there was a international foot unit that was kind of messing things up for that the UK data set. So we recently did a fix for that. And here we have some, this is a good example of that annotations thing I mentioned, where a question on the community where somebody was trying to write to annotation, but because it's a list object, they were writing a fixed field and not a list, and so that information was being lost. So this was an example on the community where we answered that question and explained how to create an annotation property. And the other one was about how to write complex geometry, and this is I just wanted to highlight this, that you can do this sort of use the transformer sequence of attribute creator, geometry property setter, and aggregator for each level of the geometry that you're creating, or you could just define the whole thing as one XML template for the GML. So you have that flexibility of doing it either way. So any of the fields that are called XML or XML_geometry, you can write XML fragments to, or any parent field you can. So that's pretty much it. There's our resources there, lots of free materials for getting started, and courses that are instructor-led and on-demand videos as well. So again, thank you so much for your time. Thank you for exploring the wonderful world of XML with us in terms of AIXM. And certainly keep your feedback coming and send us your samples, send us your schemas, anything that you're having a challenge with, and we will do our best to help you out. And we certainly are committed to this industry and to the standard. ultimately it's these standards that help systems to properly integrate with each other and keep things predictable and easy to validate. So any other questions there?
No, I think you've covered them all off, actually. I mean, just you can see the community groan of having to still work with the AIXM 4.5.
Yeah. Well, certainly, like the hope is that, yeah, we still support 4.5. Like that workspace will be, you know, we're kind of out of time now, but you can certainly play around with that workspace, and we can help you with you know, consuming 4.5 and using it to read and write to databases, no problem. But hopefully, over time, agencies will migrate to 5.1, and that will make life a bit easier. Yeah, and like I said, we do have partners out there who have a fair bit of experience as well. So if you do have a large project, you're welcome to contact our partners for more of the pro services type work. But I just wanted to say thank you for people dialing in from near and far. You know, I've seen Luxembourg and Finland and elsewhere, as well as here in Canada and the US. So yeah, it's great to hear from everybody. And do stay in touch.